Here, if you need to stop here.
Where the restroom?
No, here, over here. See the elevation difference here, and this is the scarp of the fault. And you'll see as you're coming up from low here, you've got a kind of a ramp that you're coming up. And then right in here, you see it breaking over fairly suddenly here. This is the trace of the fault. And the deformation zone extends out that way a little bit beyond here.
It's in this direction, right?
Yes. And we're going to walk along here where it's got a little bit more definition of the fall. I'm just kind of waiting on Carl for now.
So this side is the high side?
That's the up-thrown side.
Upstream.
The one we've been looking at the dam. We've been looking at this fault at the dam, and at our last stop, some distance.
Okay.
One thing. Like for instance, we'll have geomorphic features. We'll have geomorphic features. Like for instance, let's say you have a filled-in stream channel that's filling in, and you've got a remnant high bank, and it'll give you the illusion of it being a fault. But if you trace it out very far, it doesn't go very far. So you have to kind of trace these things out and map them to know what they are. We don't have a lot of geomorphic variability on the Gulf Coast. Mostly what we have is elevation differences due to salt domes. You know, we have, as you get to the western and northern extremes of the county, we're starting getting into a quasi environment where you got low angle beds outcropping that are dissected by streams. And that starts giving us a little topography as we get up around Tomball and out towards west of Katy. But so you look at features like this with a lot of suspicion, but realize they can be other things than just the fault. But when you see something like this, you have to pay attention, and you got to trace it out some distance. Like I said, there's different lines of evidence that we used to determine if there's a fault here. If we have a suspicion there's a fault here, if we're not 100% certain, but it looks like a fault, smells like a fault, but doesn't quite feel like a fault, we'll tell the client we need to do a phase 2 investigation where we drill a borehole on the high side and on the low side to determine with a high degree of certainty whether a fault is there or not. And if it's the case, these faults, the character of these faults is not continuous along their length. In some places they're better defined than other places. And so sometimes you have to go to a phase 3 drilling effort where you're drilling detailed borings to try to project that dip up to the surface, because you're not getting a really definite point at the surface of where the fault is.
Well, since they're kind of an echelon, aren't they like a undisconnected and echelon faults that
and you know, be aware of that these things are not continuous. We used to think they were fairly continuous, and they offset from tens of feet to a half a mile. So we were talking earlier about the fault that went through the former, I think it was Beckendorf Middle School up in Tomball.
Yep.
The fault ruptured that building, and they cut out a section of that building, and that didn't work. So they ended up tearing down the fault. And the fault terminated just beyond the school. What they didn't understand was that fault offset about, I don't know, a quarter of a mile to the north, and looked like it was terminating against the brand new high school building. So these things, they can die out suddenly and they can pick up suddenly. Your features, they could be old fence lines, they can be old cow paths, it can be seismic trails, it can be pipelines. So you have to be aware of what these are and typically what the characteristics of the fault look like. What's real, what's likely, what's not real. And
What about the trench?
we can do that sometimes, but it doesn't always show the fault. It doesn't always show the fault. And where's Carl?
He was
Can you show us how this lines up?
All right.
Yeah.
Let's see.
Where are we now?
North is at the top, and we're right about in here in the tree line.
And does the
Okay, so where's the pond?
Right here.
Does the fault trace follow?
See, when this photograph was taken, they drained the pond and were reshaping it.
So it sure looks man-made.
Well, it does now, but if you go back to the historical aerial photographs, you can see the pond.
So where's the fault?
Yes, so where's
The fault is
trace?
running right along in here.
So the edge of the pond is right, okay.
Right up, the edge of the pond is coming up
Thank
close
you.
to the scarp.
Oh yeah, and in fact you can see the road repaired right here.
Oh,
Well, yeah, that's probably it because it goes right in front of that building.
I was
That's
asking,
about right.
Interesting.
I was
So
asking
this-
Carl, is
the Bane Park Sag in northwest Houston. And to just give a little structural setup here, we're along the Brittmore Fault, and it's a arcuate, down-thrown normal fault at the surface. And in the park itself, you can see the fault trace coming across like so, and there is a baseball field, but this is the low sag pond right here, and it's currently filled with water, and it's all due to a drop down on the normal fault, making it a sag pond. So here's the lake.
The morphology when you were kids in school, when you have right angles in your drainage systems, what does that tell you? Structure control?
Yeah, structure.
Well, there's an indication right there. When you see 90-degree bends,
Yeah.
you know, start looking for fault.
Essentially, that's what Buffalo Bayou does in the reservoir. Because it does that big turn, cuts north, it must fall.
Yeah, but that's more broader. I would rather, what we see is, what's the name of that creek, feeds into Buffalo Bayou?
White Oak Bayou?
No, it's on the south side, starts with an R.
Rummel Creek?
Rummel Creek. Yeah, Rummel Creek is an example. Now you get up along Spring Creek, you'll see some very straight segments of Spring Creek striking to the northeast. Those are areas where I've discovered new faults in there, and I'm really suspicious along those straight line segments of Spring Creek.